to indicate heat changes in an equation. There are two types of reactions on the basis of heat changes involved. One in which during the reaction heat is evolved, and one in which the heat is absorbed during the reaction. One in which heat is released is known as exothermic reaction. When we consider the burning of carbon in oxygen, carbon dioxide is formed. Carbon in solid form, oxygen in the gaseous form, and carbon dioxide is also in the gaseous form. During this reaction, the evolution of heat is involved. So burning of carbon in oxygen is an exothermic reaction because heat is evolved in this reaction. An exothermic reaction is indicated by writing heat or energy or heat energy in the product side. So whenever we are told that a particular reaction is exothermic reaction, we should once write heat or energy or heat energy in the product side or right hand side of the arrow. When natural gas like methane is burned in oxygen, carbon dioxide is formed, and along with water molecule is formed. In that equation, heat is also evolved. We have to check the balancing of this equation when we consider C in the reactant side. One C is here and one C is here, so it is okay, and 4 hydrogen are present there, and 4 hydrogen is also here. 2 into 2 is 4. Next, 2 oxygen is here, and 2 here plus 2 here, so 4 total is 4, and heat energy is evolved. So we have to multiply this oxygen with 2 to get 4 in the reactant side, and product side it is also 2. So this is as a balanced equation also. The burning of natural gas is an exothermic reaction because heat is produced. In this reaction, the combustion reactions are also exothermic reaction. Like we burn wood, coal, kerosene, petrol, diesel, etc., etc. When we burn these fuels, natural fuels, we are getting heat energy. So these are known as exothermic reaction. What about glucose? When we consume a food, we get energy from food we eat. So the glucose, when undergoes slow combustion by combining with oxygen in the cells of our body to produce energy, it is also an exothermic reaction. Energy is released. For glucose, we write C6H12O6, that is in the aqueous solution, plus when it combines with oxygen, that is in the gaseous form, what will we get? Carbon dioxide plus water in the liquid form, and energy is released. Energy is released. When we check the balancing of this equation, we have to check first what is that C6. 6 atoms of carbon is present here, and we have to check here what is here. Only 1, so we have to keep 6 and multiply this with 6. So now it is 6 carbon. How many hydrogen is here? Hydrogen atoms are 12 in number here in the reactant side, and how many here in this product side? 12 hydrogen here, and here only 2, so we have to multiply this with 6. 6 2s are 12, so 12 hydrogen here and 12 here in the product side. How many oxygen atoms are here in the reactant side? 6. 6 plus 2, that is total is 8. So how many oxygen atom here in the product side? Here it is 8, and here it is 6 2s are 12 and 6, that is 18 here. So how will we get 18 in the reactant side? We have to make it 18 also. So here it is 6. We will not alter this one. And how many is remaining? 12 is remaining. So we have to write 6 here to get 12 plus 6 is 18 here, and 12 plus 6 18 in the product side. So this is also a balanced equation. Respiration is an exothermic process because energy is produced during the process. The burning of magnesium wire in air is also an exothermic reaction. Light energy is also produced, light and heat energy, though both are produced in this reaction. This is known as exothermic reaction. Exo means giving out energy. That is exothermic reaction. And we will learn about endothermic in the next one. Okay, bye.